Hi, in this video we're going to be calculating enthalpy using enthalpy of formation. And these are delta H F0. And as I said a few videos ago, you will be given all of these data, and it is over here. So this right now we're working on HF, so we're only going to be looking at this column. We'll be talking about delta G and delta S in a different video. So first it says using the standard enthalpy of formation values, calculate the enthalpy of combustion of 1 mole of ethane at 25 degrees Celsius. Alright, so enthalpy of formation is number of moles times products minus number of moles times reactants. So let's first read C2H6. C2H6 is going to be negative 83.75. Negative 83.75 plus 3.5 O2. O2 should be 0. Let me double check. O2 is, yes, 0. Any element that is in their normal state of matter, like O2, N2 in their gas states, and Fe in their solid state, it is all going to be 0. You'll find the trend as we do more of these problems. So this is 0, and over here it is CO2 and H2O liquid. CO2 is negative 393.51. Negative 393.51. Make sure to multiply them by their mole number. And H2O liquid is negative 285.83 times 3. And make sure you look at liquid or gas because these values are different. H2O liquid is negative 285. H2O gas is negative 241. Alright, now we have all this. It's going to be negative 393.51 times 2 plus negative 285.83 times 3 minus negative 83.75. And let's see. Negative 393.51 times 2 plus negative 285.83 times 3 plus 83.75 should give you negative 1520 kilojoules per mole. I see. All of our numbers have 2 decimal places, and this 2 and this 3 over here does not count toward our significant figures. So since we're basically adding with all of these at 2 decimal figures, when you add, you round to the least number of decimal places. Since all 3 of them has 2 decimal places, our actual value, we'll write down the actual value, which is negative 1520.76 kilojoules per mole. And that is our enthalpy. Next, using the standard enthalpy of formation values, calculate delta H. Same thing. So let's see. Product is CO2 gas. Let's look for CO2. CO2 gas is going to be negative 393.51. Negative 393.51. O2 is 0. C solid or gas. C graphite. All right. C graphite is going to be 0. So it's going to be 0, 0. So our delta H reaction is just going to be negative 393.51 kilojoules per mole. Number 3, the standard heat of formation of Br, okay, is this much. Using information to be able to find for 1 mole of liquid bentane, pentabromine. Alright, so for this one, we're going to do negative 9036.6 is equal to, let's see, first we do products minus reactants. Products is 9 moles of H2O liquid. H2O liquid, negative 285.83, negative 285.83 plus 5 B2O3. B2O3 is going to be B2O3 is negative 1263. Negative 1263.6 times 5 minus what do you have here? 12 times 0 plus x plus 2x, right? Because we're looking for B509. Basically minus 2x over here on this side. So now, what is 9 times negative 285.83 plus negative 1263.6 times 5? It is negative 8890, and we would subtract that from negative 9036.6, and we will get 2x is equal to negative 146.13 divided by 2. We'll get x as equal to negative 73.07 kilojoules per mole. Oh, sorry. This is negative 2x on this side. So it's actually going to be positive 73.07 kilojoules per mole. And the thing is, since in the reaction we're all given with 5 decimal places, so it's best if we round to 5 decimal places, 5 significant figures as well. So let me change this real quick into negative 73.065 kilojoules per mole. Number 4, using the following information to find the standard heat information for 1 mole of NO2. Alright, so first we do negative 1303.2 kilojoules per mole, and we're looking for what? NO2. We're looking for this one. Alright, so that is going to be equal to 4 times liquid water, which is negative 285.8, plus 2 times ammonia, which is 2 multiplied by negative 46, minus hydrogen is going to be H2 at its gas form is going to be 0, so it's going to be minus 2x again. Alright, so let's see. 4 times negative 285.8 plus 2 times negative 46 is negative 1235, and then we minus that from negative 103.2 to get negative 2x is equal to negative 68. Now if we divide both sides by negative, if we divide both sides by negative 2, we get x is equal to 34 kilojoules. Now let's see how much sig fix we run to. Alright, over here we use 1 decimal place, and this is 0 decimal place. So since this has no decimal places, when we're adding and in the end, we're going to remain with no decimal places. So our correct significant figure is going to be 34. Number 5 is the standard enthalpy information calculator. Alright, same thing. So H2O liquid is 285.8 to negative 285.8, negative 28.83 times 2. CO2 gas is going to be negative 393.51. O2 is going to be 0. CH3OH. CH3OH is going to be negative 239.2. Alright, so what do you have? 2 times negative 285.83 plus negative 393.51 minus a reactance, which is negative 239.2. 2 times negative 285.83 plus negative 393.51 plus 239.2 is going to get us the final answer of negative 725.95. Since our least number of significant figures when we're behind the decimal point when we added is first place, so we're going to round this to 6 and add a 0.0 behind it, kJ per mole. Alright, number 6, it says using standard enthalpy of formation values, calculate the enthalpy formation of combustion for C2H2 at 25 degrees. Now number 6, we're going to use, let's see, liquid is negative 285.83. CO2 is negative 393.51 times 2. I'm using data straight from here. O2 is 0. C2H2 is, let's quick check. C2H2 is 226.7. 226.7. Therefore, negative 285.83 plus negative 393.51 times 2 minus 226.7 is equal to, let's see, negative 285.83 plus negative 393.51 times 2 subtracted by 226.7. It will give us negative 1,299.55. Our lowest second figure behind the decimal point is 1, so we'll round this to 56. So negative 12996 kilojoules per mole. Alright, number 7, using standard for same thing. I'm gonna do the same data again. So negative 285.83 times 6, negative 393.51 times 6, 0 times 6, C6H12O6 is negative 1273.3. Negative 1273.3. And this time I'm not going to write the equation. I'm going to say it as I type in the calculator. So negative 285.83 times 6 plus negative 393.51 times 6 parentheses divided by 0 times 6 plus negative 1273 plus 3 parentheses. So that will give me negative 2802.7. Let's see, least fix 7. Yep. This is going to be the right amount. Fix kilojoules per mole. Negative 2802.7. Number 8. Write the balancing chemical equation that outlines the reaction used to determine the enthalpy formation of 1 mole of water. So what forms water? H2 plus O2 forms H2O. But we only want 1 mole of water. 1 mole of water has 1 H2, which matches over here, but only 1 oxygen. So we're going to have to multiply this by 1/2 and put this over here. So H2 plus 1/2 O2 makes 1 mole of H2O. Now same thing for the number 9, except this time we want CH2O. So C plus H2 plus O2 will make CH2O. We have 1 C, check, 2 H's, check, and only 1 O again. So we're going to have to add 1/2 in front of this O once more. And that's it for this worksheet on enthalpy of formation. Thank you for watching.